Okay, so this is the last of these videos when it comes to the chi-squared test. So this last one is a chi-squared test for independence, and hopefully, as we've done for the last couple, you've already watched the longer video that goes through step-by-step the test and how to run it. This video is just to show you how to use the link that I've sent out to get the mechanics, the expected values, as well as the chi-squared components for each cell, and then ultimately the chi-squared test statistic and the associated p-value. Okay, so you're going to see that this is actually the same link for the test for homogeneity. So there is a completely separate link for the chi-squared test goodness of fit. Again, that's the first one we did. When it comes to homogeneity and independence, it's going to be probably one of the trickier things that you'll do for this for these groups of tests for the chi-square test is to decide when you see a two-way table, is it talking about independence or is it not? Because that's ultimately the only difference is how you run the test, is how you interpret the problem. Now, one of the key things I would say is, I try my best to be as straightforward with you guys as possible. You'll notice in this question it says, is there any association? That is whenever I see that question phrased, is there an association, I immediately think, okay, they're testing for independence. All right, so just like we did before, I'm going to go to the link. All right, here it is. I'm going to type in my categories. I have for handedness, left and right. And then for eye color, we're going to have brown, blue, and other. Brown, blue, and other. All right, then hit next. All right, let's type in the observed data values. So we have 6 left-handed with brown eyes, 36 right-handed people with brown eyes, 7 blue-eyed left-handed people, 26 blue eyes and right-handed, and then for other, 6 and 33. Okay, and then you hit next. Okay, so as I said before, once you pick your significance level, I'm just going to leave it at 0.05. Like we did before with the test for homogeneity, you've got a lot going on here. Again, if you haven't watched the other videos, always read what it's telling you everything means, but I'll just give you the rundown here. So you can see the observed data values. Next to those observed data values in each cell, you have the expected values. Again, if you don't have this technology, you just have a calculator, you can always do the row total times the column total divided by the grand total. So you can, if you want, you can check out these row totals and column totals and grand total and find all of those expected values in parentheses. And then it gives you the chi-squared component for each cell, and we can confirm in the problem. If you watch the other video, you already know. But if you go to the work slide, all right, you can see right here, I have all the work shown by hand, and then you can, again, just use a regular scientific calculator to find those same chi-squared components. So that's what they have, obviously rounded a little different, but for the most part, the same problems, or the same numbers. And then if you look in the red for my screen, you can see the chi-squared statistic as well as the p-value and a conclusion, but not in context. So make sure you always write it in context. Okay, so you can see the chi-squared test statistic of 0.708, which is there, a p-value 0.702, very high, so definitely not going to be enough evidence to reject. Okay, so as I said, I'm not going to get into the specifics of your conclusions and everything for this problem. If you have not watched that full video for the independence test, please do so. Come back to this when you're ready to try the exit ticket or any type of test where I'm asking you to find some of this. You can use this link here. You can use this link to help you when you're doing your chi-squared tests for independence. Okay, good luck.